So just like every other question that seems hard, we are supposed to start with what we have and then write out the things we know, and maybe we'll be able to get to the end. Okay, so that is how. So this is just to give you some hope in case if you're finding yourself with a difficult question. Always start with the one or the fact that you know, and then also try to pick what you have in the question, and then follow the math wherever it leads, right? So this is question number 32 on stoichiometry. Once again, I'm happy to go through all this question with you guys so that by the time we do like a lot of these together, you'll be able to get better at stoichiometry at the end of the day. Okay, so if you have a challenging question, your assignment that is challenging for you, you can send it to our DMs and then somebody will reach out to you. But you should be following this page, before doing that. All right, so question 32. A divalent metal X reacts with limited HCl to produce 600 ml of hydrogen gas at STP. In question 31, we looked at how to write the equation of reaction between a divalent metal X and HCl, and we agreed that it's going to give you this plus H2. Okay, yeah, that's what it will give. And then we also balance that equation by putting a 2 there. Okay, so that is what we have. Then we are also given 600 ml of hydrogen gas being produced at STP, and the certain metal X reacts with limited HCl. So this is our limiting reagent. You see all the clues are coming out now, right? That's our limiting reagent. So what do? If that's our limiting reagent, it means that if we're to compare anything, it should be these two guys, right? The limiting reagent and the product that we're interested in, which is the hydrogen gas. The total that is 600 ml that's produced at STP, which is like 0.6 liters that's produced at STP. And we know that at STP, 1 mole of hydrogen gas would contain or occupy 22.4 liters. So if it's 0.6 liters we're dealing with, it means that the number of moles of hydrogen gas that's produced should be 0.6 divided by 22.4, and that should just give us 0.0. Hold on. 0.02678 moles of H2. So that means that that's what was produced. Alright, so now by looking at this, 2 moles of this produces 1 mole of H2. So that means this in moles, let me write it here for clarity. 1 mole of H2, so 0.02678 should give you, let's use Y this time around. So Y will be the number of moles of our HCl that was reacted. Okay. We're looking for the mass of the metal X. Okay, I chose to play with the limiting reagent. Yeah, but that's okay. You can also just choose to play directly with the X and the HCl as well. It should also work. But yeah, let's just carry on with this. So if we have 2 moles there, then we'll just get the moles of HCl that, would have produced the H2. And then we'll then compare the mole of HCl with the moles of X by dividing by 2 again to get the moles of X. So you see that that's like a long process. So let's just go with playing with the H2 and the metal directly, okay? Again, this is not wrong, it's just longer. So if 1 mole of X produces 1 mole of H2, that just tells us that this moles of H2 is also the mole of the metal X. Okay, so it means that moles of X is 0.02678 moles. I mean, this one is really clear because if this is the moles of H2 produced from this equation there, 1 mole of X produces 1 mole of H2. So that means if this mole of H2 was produced, it means it came from 1 mole of X. Is it clear now? Forget about this part. So that's the moles of X here. We know that the mass of X should be moles of X times the molar mass of X. Do we know what molar mass of X is? Oh yeah, they told us it's 24 from here. So it means that the mass of X is going to be 0.02678 multiplied by 24, which is the molar mass. And then you should have 0.6428 grams. 0.6428 grams of X, or 0.643 if you wish to put it that way. So that's how to do this question. Okay, it may look difficult at the beginning, but in summary, it was just about converting our volume to the number of moles at STP, and then relating the number of moles of H2 to the number of moles of the metal X, and then getting the mass from there. So you see, there's a way around things. If you are new to this page, kindly subscribe. If you're watching this on YouTube, subscribe, and you can give it a like if it was helpful for you, because that way people will be able to know that if they're looking for videos on stoichiometry, helpful videos, they'll be able to find this one. Okay, so this is 32. Once again, we're going to 100 questions of stoichiometry so that you guys will be able to have enough practice. Yes. So if you can sit down and watch from 1 to 100, it means that you're a good student, and then you are really motivated, and that's really amazing. Yeah, so if you're gonna watch 1 to 100, just let me know in the comments, so that I would know really smart students or really determined students. I think these videos are going to help you and other people that you would allow the algorithm, get it to by liking this post, of course. Okay, so based on that, I think we have answered 32 completely, and I'll see you on 33. I'll see you on question 33, okay? Take care.